Hoje estamos realizando o nosso último seminário do ano. Não quer dizer que não vamos deixar de realizar nossos webinar, mas esse será o último webinar do ano e teremos a honra hoje de receber o professor Peter Hotez, que gentilmente aceitou esse convite através do Ricardo e meu. E espero que vocês tenham um webinar muito proveitoso e dentro daquilo que nós já falamos nas outras vezes. As perguntas podem ser feitas através do chat do YouTube, podem ser feitas em português, sem problema, que a gente traduz aqui. Eu e Ricardo vamos ficar recebendo as perguntas, passar mais tarde para o professor Peter. Peter, thank you very much in name of the Brazilian Society of Parasitology, and it will be a pleasure for us to have you here and talk about this important program today, that is vaccine in the global health. And I go to transfer to Ricardo to introduce you for a few minutes, and then you can give your talk. Thank you very much.
Thank you, Peralta. First of all, we're really delighted to have Peter Hotez here. Peter has an extensive CV, so possibly I will need a few more days just to explain all the career of Peter. But the major importance, Peter is the Dean of the National School of Tropical Medicine, Professor of Pediatrics, Molecular Virology, Microbiology, and Baylor College of Medicine. He's also director of Texas Children's Center for Vaccine Development, professor of several universities worldwide, is really internationally recognized scientist in neglect tropical diseases and vaccine development, founder of the PLOS neglect disease. Peter has been working many years for developing vaccines against several neglect tropical diseases as hookworm, schistosomiasis, leishmaniasis, Chagas disease, MERS, and now COVID. And most importantly, I had the opportunity to work with Peter many years ago. It was about almost 20 years now. And I first had the opportunity to know how to be a scientist and how to be passionate about neglect disease and how to really be a good person and how to be kind and all the good qualities of the scientists. So today he presents his vaccine, his important work on the vaccines and all the global health. Thank you very much, Peter. It is really a pleasure to have you here. Once again, please be welcomed by the Brazilian Society for Parasitology.
Well, thank you so much, Ricardo. It's truly an honor to be here and to be with you and to also see how your career has flourished in Brazil. And I'm sorry I can't be in Brazil at this time, but we are trying to get through the apocalypse at this point, and hopefully now there's another side to the apocalypse as we all get our COVID-19 vaccines. And I'm also excited to be here because I've been talking nonstop about COVID-19 and COVID-19 vaccines. And I was thrilled when you invited me because now I can talk about something other than COVID-19 and COVID-19 vaccines. And so that's really good because the world, believe it or not, parasitic and neglected diseases did not go away just because of COVID-19. We still have those diseases, and it's really important that you're keeping them on the radar screen, Ricardo, through your work and through the Brazilian Society. So I thought maybe talk around 30 minutes or so, and not because people are sort of inundated with too many PowerPoint presentations. So talk a little bit, a broad overview, but try to leave time for questions and answers. I think that would be very productive.
Perfect.
All right. So let's see how this goes.
Júlio, coloca a apresentação do...
Yeah.
All right. Green light to go ahead?
Yes. Go
ahead. Excellent. So, it's not advancing. Let me use the other one. Yeah. All right. So let's go back. When Ricardo and I worked together in Washington, D.C., while we were in the lab, this was going on. It was this global framework for addressing poverty. And that's really where this concept of neglected tropical disease came about. It was bringing all the global leaders to United Nations headquarters in New York, and people like Bill Clinton and Kofi Annan. And this is when we created our 21st century framework for tropical diseases, and it was done under the auspices of what's called the Millennium Development Goals. And what was so forward thinking about it at that time was the idea that infectious diseases would be linked to poverty, and there was a specific goal for infectious diseases called to combat HIV/AIDS, malaria, and other diseases. And this is what led to the President's Emergency Plan for AIDS Relief from the U.S. government, the Global Fund to fight AIDS, TB, and malaria. And unfortunately, for the diseases that occupy the Brazilian Society of Parasitology, of course, malaria is prominent, but there are a lot of other diseases as well. And they called them other diseases, which was not very nice, because all of a sudden, all the diseases that we work on were just called other diseases, and we needed a framework. So the point is, this never happened. When Bill Gates and Tony Blair and Bono got together, it was all about focusing on HIV, AIDS, and malaria, not so much other diseases. And this is when I took a step out of the lab to really do some advocacy and really branding. And I worked with David Molyneux in Liverpool and Alan Fennick in Imperial College London and Lorenzo Savioli, who is at WHO, to brand together around 13 or 14 tropical infections that was later expanded to 20 by the World Health Organization, with the following features: that they were highly prevalent among the poor, they were endemic in rural areas of low-income countries, not so much emerging, but in fact they've been around forever as far as we know, ancient afflictions, and they tend to be chronic and destabilizing conditions, also highly stigmatizing in the fact that they both occur in the setting of poverty and they promote poverty. And we wrote these two back-to-back papers in PLOS. Back then, PLOS NTDs didn't exist, but we actually used our papers in PLOS Medicine to leverage to create PLOS NTDs, and we put them in PLOS Medicine. And we think this may be one of the first times that the words NTDs, or neglected tropical diseases, as a brand appeared in the biomedical literature in 2004, 2005. And so now we've written books about this, and it's starting to gain some momentum. So this is now the list of 20 illnesses that we call neglected tropical diseases. Again, a lot of parasitic worm infections, including ones that are extremely important to Brazil, including schistosomiasis and intestinal helminth or soil transmitted helminth infections, and lymphatic filariasis, which is still found in cysticercosis, and we have leprosy and trachoma and Buruli ulcer in Brazil, and of course dengue and chikungunya and Chagas disease and leishmaniasis, all basically under initial name of the other diseases, now branded as neglected tropical diseases. And as I said, as Ricardo mentioned, the book was, I wrote my first single author book called Forgotten People, Forgotten Diseases, and launched PLOS. And this is the latest iteration in 2017. There's now a new iteration in 2019. So this is from the Global Burden of Disease Study from the Institute for Health Metrics. And it essentially shows that hundreds of millions of people are infected with neglected tropical diseases. And we used to call the people who live in extreme poverty the bottom billion, and now it's around 750 million people. And basically all of them are infected with one or more neglected tropical diseases, led by the intestinal worm infections. And now the World Health Organization has added scabies, and then schistosomiasis. This is dengue, which is an incidence rather than prevalence. Foodborne trematode infections, lymphatic filariasis, onchocerciasis, Chagas disease, cysticercosis. The point is, most of them, but not all, but most are parasitic infections. and every single person living in extreme poverty is infected now with at least one of these conditions. And now the global burden of disease has just put up the 2019 numbers, and I haven't had time to update the slides. I don't think it's going to be that much different for a couple of reasons. One, now, although there's been a decrease in global poverty overall in this last year, the new estimate from the World Bank is 100 million new people have been added back into poverty, especially in India and DR Congo and Nigeria. So now the numbers may go back up. So I'm worried now the neglected tropical diseases will resume. One, because of COVID-19, where it's interfering with our ability to do mass treatments, but also because of the just the impact of the global economy and the fact that more people are being thrown into poverty. Poverty is a risk factor for neglected tropical diseases, and neglected tropical diseases reinforce poverty. So they're conditions that I know everyone here has devoted a lot of time to, but the reason I'm showing these slides is many of them are not fatal diseases, and this makes it difficult to get people to care about them. So with so many people, especially this year, dying of COVID-19, to get people to care about people who are not dying necessarily, but debilitated and thrown into poverty because of these illnesses is hard to keep it on the radar screen. One of them that we're working very hard to get people to care about is called female genital schistosomiasis, particularly in Africa, caused by the urinary tract form of schistosoma hematobium. We used to say it was the urinary tract form. Now we realize it's the urogenital form. Is up to 40 million girls and women in Africa suffer from pain, bleeding, stigma, depression as a consequence of this condition. And now it's been linked to a 2 to 3-fold increase in acquiring HIV/AIDS. And this brings up another important issue is all of our diseases that we study in the Brazilian Society of Parasitology are fellow travelers with things like HIV/AIDS and tuberculosis. So they're not mutually exclusive. And looking at those interactions, I think, is extremely important. So our initial attempt at looking at how we're going to do global control of neglected tropical diseases really revolved around mass drug administration, or now what the World Health Organization calls preventive chemotherapy. And the idea is that we do not have to diagnose everybody with a neglected tropical disease. If we know the community prevalence, we can embark on mass treatment with repurposed medicines. And this is what David Molyneux and Alan Fennick and I began looking at, is how to package these together in order to target initially 7 neglected tropical diseases: ascariasis, trichuriasis, hookworm, schistosomiasis, lymphatic filariasis, onchocerciasis, and trachoma. Certainly for Brazil, but the original plan costed out this package at around 40 cents a person, global health intervention. And now, through that advocacy, the United States Agency for International Development, United States Agency for International Development, USAID, estimates that a few years ago we reached the 1 billion person mark, and now annually we're treating these populations at the level of 1 billion people per year. And this is the funding that we were able to mobilize from the U.S. Agency for International Development. We were really, started out modestly at $15 million a year, but at 40 cents a person per year, we could still treat, 30, 40 million people. And then we started to gain momentum. And then in the Obama administration, and then we kind of got stuck. And certainly in the Trump administration, things have been flat, which in some ways is a victory because we were worried it was going to really be cut entirely. But the fact that we've been able to keep it around $100 million a year and get bipartisan support in Congress has been helpful. And the goal is to see through mass treatment whether we can actually eliminate some of these illnesses, such as lymphatic filariasis, onchocerciasis, trachoma, and ascariasis, as well as to create some reductions in the other soil-transmitted helminths, as well as schistosomiasis. And the argument that we often have now with the global policymakers is there's disagreement. They think that we can completely eliminate these diseases through mass treatment alone, and I don't think that's the case. I think clearly we're going to need wash and water, sanitation, and hygiene, but I also think we're going to need additional interventions. The other thing that we noticed, and we published this last year in the New England Journal, is we're starting to see collateral benefits that we never thought we would see. And that is that the mass treatment that was really being targeted for the 7 diseases, as the 3 intestinal worms and schistosomiasis, lymphatic filariasis, onchocerciasis, and trachoma, also started reducing yaws, I think because of the azithromycin component. Ivermectin has been reducing scabies and strongyloides. We're now almost eliminating this intestinal worm called esophagostomiasis. And then some surprising effects as well. And the biggest surprising finding was Tom Leitman at UCSF, University of California, San Francisco, did an analysis in Ethiopia and found that there was a sharp reduction in child mortality. And that did not make any sense to us because none of the medicines that we use in the package are really targeting fatal diseases. And so why is overall child mortality decreasing? And we don't know the answer, but it's more or less held up in additional studies supported by the Gates Foundation in Africa. So we think possibly maybe it's reducing pneumococcal carriage or diarrheal disease pathogen carriage, and that's something that we're looking at. The other collateral benefit, and now there's some studies showing that individuals who have high levels of ivermectin, as the Anopheles mosquitoes come in and bite individuals and take up the ivermectin in the bloodstream, it's having a detrimental effect. So potentially it's going to be a backdoor way of reducing the incidence of malaria. Now, that's been the successes. What's been setting us back has been the fact that we've seen a slowing of those successes or even a reversal in certain parts of the world. So we've seen now a sharp increase in neglected tropical diseases in parts of Central Latin America, especially in Venezuela, in parts of sub-Saharan Africa and the Arabian Peninsula, and even in the Gulf Coast of Texas. And we're trying to understand what it is that's causing those recurrence. And this is a new book that I'll have out in January. It's called Preventing the Next Pandemic, Vaccine Diplomacy in Time of Anti-Science. And the title emphasizes vaccines, but it also looks very closely at neglected tropical diseases. And one of the things we're finding is that these hotspot areas where we're seeing a return of parasitic and neglected diseases are in areas where political instability is combining with climate change, urbanization, deforestation, and even anti-science activities. And it looks at how they're combining in unique and interesting ways to bring back disease. And do a whole chapter, for instance, on Venezuela and what's happened there in the Maduro regime, and the fact that there's been a sharp increase in malaria due to the illegal gold mining industry, which in turn is due to the depressed economy. So immunologically naive people are now sleeping outdoors without bed nets in the gold mines and then getting bitten by mosquitoes, which are causing a big rise in malaria. And with Venezuelan scientists, we're starting to look at this. And then, of course, it's spreading laterally and to Colombia, especially among indigenous people like the Wayu indigenous people in Colombia, and into Amazonas and Roraima State in Brazil, and basically says how these forces are combining to bring back disease. And it's a useful point to make because, as parasitologists, as biomedical scientists, none of us get training in political instability or maybe climate change a little bit now, urbanization or anti-science forces. So it's a call to say we need to broaden our training for our doctoral and postdoctoral level scientists, because these are big drivers now for parasitic infections. The other force that I look at is this concept I call blue marble health, which is when you add up where most of the poverty-related diseases are, including parasitic infections. And we find something that was originally a bit counterintuitive, and that is they're mostly in the G20 nations, including the US and Mexico and Argentina and Brazil. But it's the poor living among the wealthy accounting for those illnesses. So the typical narrative of global health, it's wealthy countries versus poor countries, and we think about fragile nation states in Africa. But in fact, it's on a numbers basis, it's the poor living in the wealthy G20 nations that account for now about half the world's worm infections and leishmaniasis and tuberculosis and dengue and Chagas disease and leprosy. And I've given it a new name I call Blue Marble Health, which is a 2016 book. And to say it's, not wealthy versus poor countries, economies are rising, but leaving behind a bottom segment of society. And that explains why you have a lot of parasitic infections in southern Mexico or in southern United States and parts of northeastern Brazil and even northern Argentina up in the Chaco area. And it's an idea that is not really caught on. It's not widely accepted by the global health policymakers. So I'd be curious to get your thoughts on this as we move forward. So, for example, in the U.S., together with Rogelio Mejia in our group, who's spent a lot of time in Brazil and Latin America, when we started to go to poor neighborhoods in places like Alabama, we found hookworm, Indicator americanus transmission, and of course Ascaris as well. And these are illnesses people thought were long gone. And it goes to show you that if you take the time to go into poor neighborhoods and look, you can find all sorts of things. It's just that most of the time we don't bother trying to measure this or look, and that's why they get missed. So in 2017, Phil Alston, who's the UN Special Rapporteur on extreme poverty and human rights, came to shine that global health lens inward, on the United States in this blue marble health concept, and I think was quite important. So we work in Texas. People think of Texas as a wealthy state, and there is enormous wealth in Texas, but there's also extreme poverty. We have 5 million Texans living in poverty. And, and a lot of it, of course, is in the border with Mexico. And this is what it looks like, discarded tires and, substandard housing. But it's not only in Mexico. This is just a few miles from my medical center where I work. And you have the discarded tires, they're Aedes aegypti mosquitoes there transmitting dengue and Zika and chikungunya and low quality houses. So the point is, we have a lot of poverty-related diseases here. And one of them that I'm very interested in looking at with Ricardo as well is toxocariasis. And we're finding this is pretty widespread among the poor in the United States. And so Rogelio and a former fellow of ours, Donna Tayungo, is now at the University of Oklahoma, did a survey, for instance, of all the public parks in Queens and Bronx, Manhattan, Brooklyn, Staten Island, found a lot of toxicara, and it went along a poverty gradient. So no surprise, it's the highest in the Bronx and lowest in Manhattan. So it really very much is a disease of extreme poverty in the United States. And together with Robin Gasser and Ali Rostami in Iran, we've done now try to do our first estimate of the global burden of toxocariasis, because it's not even mentioned in the global burden of disease study. So we've been really trying to do some systematic reviews on how extensive this is. And so when we always talk about the intestinal worms, of course, we talk about ascariasis and trichuriasis and hookworm, and then sometimes we ask strongyloidiasis. I think toxocara is extremely important, and I know there's a lot of expertise in Brazil, and we're trying to raise awareness about this because we think it's important from the standpoint of the not only just the full-blown visceral leishmaniasis or visceral larva migrans or ocular toxocariasis, but also the more subtle effects in what we sometimes call covert toxocariasis, where kids especially have eosinophilia, and many of them have cognitive and developmental delays, and I think it's due to toxocara. So I think as a group, we need to do better raising awareness about this. I think it's extremely important as certainly any of the other parasitic infections. We just tend to not really highlight how common it is and its long-term effects. And we need many more clinical studies. And a lot of my thinking about toxic hair is from work from Brazil and members of the Brazilian Society of Parasitology. So finally, we get to, what do we do to vaccinate against some of these diseases? The idea is mass drug treatment will only take us so far. And part of the problem is around this innovation gap, which Carlos Morel was so instrumental in formulating when he was head of TDR, that meaning that the 90% of the research dollars are going for diseases that occur only affecting 10% of the population. And we need to have better support for research for the diseases in the global south. So this is a money map basically showing where all the funding is going to, and we need to really expand this part of the pie of Africa, Latin America, and South Asia. So in terms of vaccine development, some of the big problems that we're having is bridging this so-called valley of death. And the two big ones are that I think about is there is support for basic science research on the one side of the valley, and there is support for clinical trials, but it's hard to get support to bring the new discoveries into the clinic. This is what I mean by the valley of death. And so how we bridge that. And when Ricardo joined us 20 years ago, when we were in George Washington University, then a decade ago, we moved to Texas. We were trying to really find a sustainable business strategy in order to bridge that gap. So it wasn't only just a problem in science, it was around sustainable business funding. And a lot of that work is being done through nonprofit organizations, what are sometimes called PDPs, or product development partnerships, which includes our Texas Children's Center for Vaccine Development, but there's about a dozen of them with varying degrees of funding. The small molecule drug ones have been better funded more consistently by Gates and others than the vaccine ones. I think most of the vaccine product development partnerships really are struggling. I mean, ours and Aris is now gone. There's still IAVI. Path vaccine is still around, but trying to identify a more sustainable model. And I think this was very important for innovation, and I think we can keep that PDP concept alive. But this is a great opportunity, I think, for Brazil to start to help create something along those lines. And critical for that are not only the PDPs, but the group that calls themselves the DCVMN, the Developing Country Vaccine Manufacturers Network, which is around 39 manufacturers from 15 countries. That's really playing an important role with COVID-19. Now you have Butantan, for instance, leading the development of the AstraZeneca Oxford vaccine, and Biomanguinhos is pursuing one of the Chinese Sinovac vaccines. But quite honestly, I would have liked to see more new vaccines coming out of Brazil rather than through those partnerships. And I'd like to see more activity in Latin America. There's too few. I mean, really, what are our choices? Our choices are the two major ones in Brazil. Cuba does some, Mexico does some. But for instance, we'd like to transfer our COVID-19 vaccine, which we're producing in India now. It's a recombinant protein vaccine. It looks really good. We're scaling it up in Hyderabad, India. How can we transfer the technology to one of these developing country vaccine manufacturers? So I think the quality of the existing ones is quite high, of course, with Butantan and Fiocruz, but I'd like to see more, and I'd like to see more effort on new vaccines. So this is an example of some of the major neglected disease vaccines being accelerated. I sometimes call them the anti-poverty vaccines because they have an impact not only on improving health, but because the neglected tropical diseases actually promote poverty, the vaccines themselves could be anti-poverty measures. And you can see that the portfolio of vaccines in clinical trials that I identified are still pretty modest. I'm sure there's others in Brazil that you can tell me about, and they take quite a long time. And we've seen how when there's political will, you can advance uh, you can advance parasitic disease vaccines. You can advance a COVID vaccine very quickly. I think we could do the same with parasitic disease vaccines. It's just that they tend to go very slowly because of the shortages of funding. So we have a Chagas disease that we're developing now with a consortium of Mexican institutions, as well as a leishmaniasis vaccine. And I know there's been a lot of work in Brazil on leishmaniasis vaccines. These are some of the worm vaccines, including with Texas Children's and PA Life Sciences. Biomanguinhos now has been working with Miriam Tendler's group to develop a schistosomiasis vaccine. But all of this is going slower than it should, in part because of the level of funding that we're getting. So these are the ones that we're involved with, but I know there's a lot of activity in Brazil, and this is our Texas Children's Center for Vaccine Development that's co-headed jointly by myself and Mary Elena Patazzi, of course, who has been to Brazil many times, and some of our best memories are our partnerships with Butantan and Biomanguinhos. And we try to build out these functional units and core competencies, making kind of a hybrid between an academic institution and a biotech, and it works with varying degrees of success. I think if we went to the pure biotech model, it's been really tough to get venture capital funding and other sources of funding. So making this hybrid with academia has been useful, and also incentivizing people to maintain academic careers. And here's where we're at with our portfolio now, and I'm happy to say now that we're moving really rapid. This is before COVID-19. Now we're really moving very rapidly on COVID-19 to the hope that we'll move into phase 3 trials very soon. So, the schistosomiasis vaccine, we started in 2004. And so 16 years later, we're still at phase 2 with adequate funding. Now the COVID-19 vaccine could potentially reach emergency use authorization and licensure over the course of a year. Now, admittedly, it's not as complicated a target, but you get the idea. Now, what we try to do with our parasitic disease vaccines whenever possible is to follow the lead of Rino Rappuoli, who pioneered this concept of reverse vaccinology, reverse engineering vaccines based on in silico approaches looking at the genome. And he did this initially with Neisseria meningitidis serogroup B. And it's really very elegant how they went from 600 potential vaccine candidates, and then expressed 350 of them in E. coli. So sort of high throughput, moderate throughput expression, identified 91 surface exposed proteins, then determined 28 have bactericidal activity till they made their final down selection. So that's really our aspirational goal. But it's been a bit of a holy grail for us, because for parasites, since they're complex eukaryotic organisms, they have large genomes, of course, that are similar in complexity to the human genome. And oftentimes we cannot express them in a high throughput way in bacterial expression systems. You get aberrant disulfide bond formation and inclusion bodies, and it's often hard to refold. So we'll often go to yeast, and sometimes that's successful, either Pichia or Saccharomyces. More often than not, we have to go to insect cells or mammalian cells, and that will slow you down, and it gets expensive. So it's really low throughput, not high throughput. And then we have a lot of deficiencies in the animal models. But having said that, we have made some progress on accelerating vaccines for hookworm and schistosomiasis. Now in phase 2 trials for both in the hookworms and schisto vaccines in Uganda, especially, and Gabon as well. And we've just published the Gabon phase 1, phase 2 clinical trials. And of course, a lot of work in Brazil with under the leadership of Rodrigo Correa Oliveira and people like Jeff Bethany and David Demert at Hene Hashu, and also with the Federal University of Minas Gerais, has been so important in getting us to this various step. Now we have a Chagas disease vaccine it's a recombinant protein together with a TLR4 agonist that Catherine Jones is leading in our group. And we're able to show that when you give benznidazole, it often does not reduce the number of parasites in the heart or the inflammation and the fibrosis. And yet when we add on our vaccine together with it, it really expands the activity of benznidazole. So this is now going into phase 1 trials in Mexico with support from the Slim Foundation and the Kleberg Foundation. And then our leishmaniasis vaccine is jointly with Jesus Valenzuela, Chad Kamhawi's group at NIAID, focused more on old world leishmaniasis, in which we're combining LDNH 36, the parasite antigen, together with sandfly antigens, and we're looking at from Phlebotomus palpatazzi, this salivary protein, which they had shown will give greatly augmented immunity. So we're looking at this as a bivalent vaccine that we're hoping to get into the clinic as well. So I'll stop there and just say, when we talk about the rights of human beings to food, water, and shelter, even essential medicines, I would add one other, which is the right of access to innovation. We really do need to think of that as a human right, so that a scientist who's also a human being can't rest while knowledge, which might reduce suffering, rests on the shelf. And let me stop there and see if we have some time for questions, and just kind of taking that 30,000 foot aerial view and get your thoughts on all of this.
Thank you very much, Peter. It's a beautiful presentation. Well, what I can say more? We would like to have much more plants to produce vaccines. But do you think, my major question here, we have some question already in the YouTube channel, but don't you think that it's proportional to the investment? Because here in Brazil, I know that it's like Trump government over there. When we believe the science is a cost, not an investment. So this is a twist. It's a hard.
Yeah, I mean, I totally agree. I mean, one of the things about COVID-19 that I hope it taught the world is that infectious diseases are not just public health issues, right? I mean, look, it collapsed the global economy. It's created insecurity. These are global security issues, and we have to kind of treat vaccines and research almost like we do nuclear deterrence. I mean, nobody has any problem investing in nuclear deterrent technology, but we don't think about pandemic threats or epidemic threats. So I think that's one thing. So really expanding the level of investment. I'm hoping COVID-19 will be a lesson. But, then again, I thought after SARS in 2003, the world would wake up and say, want to invest in infectious diseases. Then I thought after H1N1 in 2009, but no real quantum leaps. Then after Ebola in 2014, now this. So that's one problem. The other piece to this, of course, is the simple reality that some of these virus targets are not as complex. I think one of the lessons learned that we're working on coronavirus is the spike protein of the coronavirus is a soft target. Pretty much anything you use that induces virus neutralizing antibodies works. That's why, the mRNA vaccines work, our recombinant protein vaccine works, the AstraZeneca adenovirus vaccine work, particle vaccines work. They all are going to work because it is a soft target, or some people call it clumsy prey. Unfortunately, parasites are not as amenable. I mean, what if COVID-19 turned out to be not so straightforward a target? And remember this also, knowing to target the spike protein, that wasn't by magic. That was 17 years of research and development that we and others did. So we had 17 years of support from NIH and other sources investing in coronavirus vaccines. So people, say it's a miracle we did this all in 5 months. It's not true. This was a 17-year vaccine development project. I think that's the other thing. But clearly the investment is too small. I think the other problem is the way we think about these parasitic infections from a prioritization point of view. For HIV/AIDS, nobody would argue. Everyone say, yeah, you need vaccines, you need drugs, you need diagnostics. Same with malaria. You need vaccines, you need drugs, you need diagnostics. But all of a sudden for schistosomiasis, oh, you only get one thing, right? Here's praziquantel, enjoy. That's it. And we've got to get away from that. We have this kind of one shot on goal mentality for our parasites but leishmania or trypanosomes are every bit as complex as HIV or anything else that we study. But somehow the message subliminally that we get is you only get one intervention, and that's not the way it should be.
Yeah, because the question here is the parasites are much more complex. So not that saying that make a vaccine against COVID is kind of easy job, but we now have seen that all the worldwide effort to produce vaccines, several types of vaccines against COVID. Don't you think now, what's your opinion about the future of the parasitology and at least the research of the vaccine for parasites? Because don't you think it will be much more neglected over the next years? Because right now they will say, okay, it's important to do a vaccine against COVID, no question about it. But how about a vaccine against leishmaniasis? What for schistosomiasis?
Yeah, well, if you ever watch a bunch of little kids play football, you know how it works. It's not like a professional soccer game. When a bunch of 4 or 5-year-old kids play football, the ball goes over there and all the kids run over to that ball. Nobody stands back and plays defense. And this is what's happening globally now with COVID-19. But we still need to target leishmaniasis and Chagas disease and toxocariasis. So we have to figure out how to do that. One of the benefits, though, could be the fact that, this is proof of concept that mRNA vaccines and adenovirus vaccines can deliver antigens in interesting ways. So I'm hoping it'll expand those technology approaches for parasites. So we have an RNA vaccine program for Chagas disease, and it's certainly an interesting approach, and maybe it'll provide some added incentive. Historically, we've always done traditional vaccines for parasites, mainly focus on recombinant proteins. But I think bringing in some of these new platforms will help the field somewhat. Oh, you're on mute.
Yeah. Excellent. We have some questions here from YouTube, just to acknowledge that we have people all over Brazil, parasitologists all over Brazil, Argentina, Campus Neto from Boston. So we have people. So one of the questions is, Peter, do you think that we don't have a good vaccine for leishmaniasis, at least in place, just because we have a lack of knowledge or a lack of money?
Well, it's clearly both. But again, groups will start their work on leishmaniasis vaccines and then get interrupted for a lack of funding. And clearly, if we could create a fund for that purpose, we would crack it, I think, just like we did for COVID-19. And so one of the things that we've been working on is to try to get people to care more about leishmaniasis. Particularly for cutaneous leishmaniasis, we dismiss it as a benign disease or not important. So with David Molyneux and the group in Liverpool, what we did was, and Acosta Serrano and others, is to look, these permanent scars have massive mental health effects, right? And social stigmatization. How can we quantitate it? So, this number of 2 million people have cutaneous leishmaniasis, it's not true. People will often have this scars their whole life. So it's more like 40 million people. And we need to do better estimates of disease burden, I think, in order to get people who are not working on leishmaniasis to care about it. So I think often as advocates, we don't quite know how to press the right buttons to get people to care about our diseases. And I think the disease burden is one of the first things we need to do. I think also we need to get people to understand that these illnesses are so important for girls and women also, because there's a lot of interest in girls and women, but we don't ordinarily frame are parasitic diseases from that standpoint. So that was the idea behind female genital schistosomiasis. If you go to a conference about girls and women living in poverty, you hear about domestic abuse, of course, and you hear about inequality, and you hear about female genital mutilation. But here, female genital schistosomiasis is an illness of 40 million girls and women in poverty in Africa, maybe the most common gynecologic condition on the African continent. And nobody talks about this illness at conferences on girls and women. That's our fault, that we don't know how to reframe our diseases to the global policymakers to get people to care. So I kind of did not answer your question. I mean, I clearly said, the funding is not adequate and we need better funding. And these are some of the ideas behind it. I also think, there's a lot more need to understand the basic immunology of leishmaniasis. There's so much good work coming out of Brazil that's important.
Thanks. We have a question here from Antonio Campos Neto. Peter, what do you think? Please ask Peter if he thinks that a recent blue wave in the US will help to improve the blue marble health. Do you think this blue wave will help at all?
Well, things cannot get worse, right? I mean, look at what we've had. The U.S. is pulled out of the World Health Organization. We are not part of the COVAX facility. President Trump just issued an executive order saying all COVID vaccines belong to the United States, America first. Even, I don't know how he enforces that, considering the Pfizer vaccine is also made in Belgium and Germany, but that's, this has been very damaging. And of course the response, right, which is to downplay the importance of COVID and say the deaths are due to other reasons and spectacularize hydroxychloroquine. We are in a whole new world of anti-science now in the United States. So there's about almost half the U.S. now doesn't believe that COVID-19 is real. And we have people, dying in the intensive care units whose last words are, "This is all a hoax, it's not real." And they're not even dying with dignity. And so how we reverse that anti-science, I think, is going to be really important. And again, this is why something like the Brazilian Society of Parasitology is so important, just reminding people of the importance of science and illness. So I think things will get better from that standpoint, but there's also a lot of damage control that has to be done as well. But I'd be curious on your thoughts as well.
Well, the thing is, here in Brazil, we have this saying that I say, okay, some people are saying it's hard to believe that it would be worse than that. But they are really creative guys here. The politics are really creative. They can really take money and the parts and they shouldn't. But I mean, we have much more questions.
The thing that I worry about, the other thing I always worry about is, with this rise in anti-science in the Trump administration, had he gotten reelected, I don't know if there was a Republican Senate as well. I don't know what have happened to the NIH budget. He tried to kill it before, or really decimate it, or the National Science Foundation, or our scientific institutions. So, so even something like the NIH and NSF are still fragile. And I would imagine it's the same with, the public universities in Brazil and Fiocruz, that, the several years of the wrong politician could really decimate the budgets of our scientific institutions.
Yeah, we have one related question here.
Can I just say one other thing about this,
sure.
Which is,
go ahead.
The message we always got as scientists is that, we're not supposed to be involved in politics. Let the politicians do the politics and the scientists do the scientists, and you don't go there, right? This is our training. We just got to stick to the science. And I've always really tried to adhere to that. But then what do you do when the president's chief COVID advisor, Scott Atlas, starts calling COVID a hoax and says the deaths are not due to COVID, and and talking about hydroxychloroquine and saying discrediting face masks. And you know, my wife Ann looked at me and she said, Peter, this is making you crazy. You just have to go into the political realm. And I did. And so all during the summer, I went on attack and really, you know, explained to audiences on, you know, CNN and MSNBC. By then, Fox News had cut me off, but on CNN and MSNBC, what's going on, and saying this is a deliberate anti-science disinformation campaign. And nobody was happy that I did that. I mean, my bosses at the university are not happy I did it. I don't think they supported me, of course, but um, it took me in a very dark place, you know, going out of my comfort zone. But the way I say it is, look, I didn't link the science to the politics. They linked the science to the politics, and I'm trying to disentangle it. And we'll see how well it works. But it's been a very, very tough year because of that.
Yeah, but relate to that, we have this question from Carlos Graf Teixeira. He's a former president of our society.
Sure. Hello, Carlos. How are you?
Do you think this anti-science, anti-vaccine movements is just a lack of ability of our scientists to communicate very well to the society? Because, of course, we have to acknowledge that there is these people that do not believe in science, all the plain Earth and everything, that vaccines is really cause autism.
Yeah, you know, I absolutely think you're right. I think he's right. I mean, you know, again, when we were being trained as scientists, right, you know, the message we got was, okay, you don't talk to journalists. You're not supposed to talk to the public directly. This is seen as a form of self-promotion or grandstanding. And the scientists who did that, we kind of put them to the side. And, you know, all those ideas, you know, came out of German universities in the 1850s, right? And the world has changed, and now we have something called the internet, and we have something called social media, and I think we have to go the opposite direction. So I have a paper in PLOS Biology. It came out earlier in the year and said, no, we have to now start thinking about training scientists in public engagement and how to do science communication, because there is a way to do it. But it's not in the DNA of our profession. So, for instance, you know, in our annual evaluations, right, I get evaluated too. And what's on the evaluation form? Well, it's got my grants, and it's got my papers, right? And then it's got my grants, and it's got my papers, and it's got my grants, and it's got my, they don't care, right, that I spoke on CNN or even wrote books or wrote op-ed pieces. But so it's not in the DNA of our profession to do that. I think the other piece to this is recognize how pervasive now this anti-science movement is. It's, you know, there's more than 500 anti-vaccine websites. They dominate the internet. They dominate social media. If you go to the Amazon website now and put them, you know, everyone's done this. You put books up at the top and press return. You get the scroll down menu at the left on health, fitness, and dieting. And then you click on that, go to vaccinations. It's all fake anti-vaccine books, right? A lot of them against me in particular. Now Robert F. Kennedy Jr. has publicly labeled me the OG villain, and I had to look it up what it means. It means the original gangster villain. So you're listening to the original gangster villain today. These guys are not, these are bad guys, right? These are really aggressive. And now you have the Russians on top of it, flooding our internet with what's called weaponized health communication. So what was kind of a local homegrown anti-vaccine movement is a full-on anti-science movement, and it's supported by far right-wing extremists. It's also now being heavily influenced by the Kremlin and Putin and the Russian government. And again, you have to be careful how you say that, because if I start saying, if I start talking about QAnon and Russia and you know, neo-Nazi groups, I start sounding like a conspiracy theorist myself. I start sounding like somebody who throws things at the TV at night. So we have to find a better way to communicate all of this.
Do you think they will take the vaccines? These anti-vaccine guys?
Well, the hesitancy is pretty high. It's about half the U.S. population says they won't. I think the numbers will improve a little bit, but we're going to have to improve our communication if we're serious about doing this.
Okay, Peter, we have just two quick questions. One's for Luisa Magalhães from UFMG. Do you think these helm infections, particularly those that migrate through the lung, might influence the COVID-19 clinical outcome? Because now we know of, just people from the hospital, major people that has managed to go to the hospital. But how about the people that get COVID and also has helminth infections? What do you think about
it? It's an important question, right? Are they immunomodulating the host for better or for worse? Do they get sicker? Is that a reason why there's more COVID-19 in low-income neighborhoods? People assume it's because they're essential workers, they're working on construction sites and family-owned restaurants, and it's exposure. But who knows? Maybe there is an impact on helminth infections one way or another. I think the other big mystery that I don't understand is what's going on in Africa. The numbers just are really low numbers of COVID-19. Is it real, or is it they're not being accounted for? Is there something unique about the populations there, the environment, that's causing protection? I think that's, to me, one of the big mysteries is why did Brazil get hit so hard, but the African countries so far not? And to me, that's a really important question.
And another question from José Roberto, also José Roberto Machado, also former president here of our society. Do you think how is the expected success of a soil transmit vaccine without the change in environmental conditions? Because we are thinking about vaccines against soil transmit helminths, but we know that it's not connected with all the environmental changes, all the deforestation. Do you think the vaccine against soil transmit helminths would be successful, even though we do have all these environmental conditions?
Yeah. So in the new book, one of the things I say is, you have opposing forces, right? You have new vaccines that are being developed, but what's fighting against this? All these social and physical determinants, right? It's climate change and deforestation and poverty and urbanization. In fact, I think the original title of the book was going to be, vaccines and neglected diseases in a time of war, poverty, political collapse, climate change, urbanization, deforestation, and anti-science. But the title was longer than the book. But you get the idea. This is, and again, as biomedical scientists, as parasitologists, we don't get training in any of those things. And maybe we need to broaden it, or we have to learn to collaborate better with the social scientists. And the funding agencies don't like that, right? They like us to stay in our lane. Okay, you just study the parasitic disease. Okay, if you want to work with an immunologist or molecular biologist, that's okay. But you can't work with a political scientist or an anthropologist. And yet we're going to need to if we're going to solve these very complex problems.
And just one last question. Of course, we have so many questions. Unfortunately, we won't have time. I will really ask really I'm ashamed because
we'll just do a follow-up fireside chat, maybe.
Yeah, we can send you the questions later. But were really interesting questions. We have this one from Mariana Clinical, a young scientist in Brazil. She wants to know if you have any advice to give young Brazilian scientists that are not only going through a lack of financial support, but also living this under anti-science government. How are you going to say to these young scientists now in Brazil?
Yeah, it's very tough. And it's not just in Brazil. We have, I'm really worried with the downturn in the economy. What are the job prospects? And what I would say to this is, be open-minded in your career. When I was being trained and getting my degrees, the message was, your goal is you have to get to a postdoc, then you have to become an assistant professor, or then associate professor, then full professor. And everything else we used to call alternative careers. And we have to get away from this idea. We need doctoral level trained people across society. We need doctoral level people trained to teach in the public schools. We need PhDs in the government, right? I mean, we don't have them, at least not nearly enough. So we need doctoral level. So one, I would say we need doctoral level scientists trained, out of this mode that they have to become assistant professors at a major university and have them throughout society, because that's the best hedge to prevent this from ever happening again. I think that's going to be really important. I think the other is getting trained abroad is really, I mean, the one people say, well, Peter, do you have any regrets? Not really, but sometimes I wish I had spent time training in England or France, to see how science is done differently. And I think that would have made my life richer, in learning another language as well. And I would just say be open-minded and be adaptable and be prepared that you may have to move. In the U.S., it's quite common to move. Right, I was on the faculty at Yale for 11 years, and then GW for 11 years. Now I've been in Texas 10 years. And that's been really great for my science and for my marriage and everything else. In Brazil, that's less common, right? It's usually you often stay at the same place where you do your doctoral training. I hope that can change in Brazil, because I do think it's good to move every 10 years because it freshens your science and makes you think in different ways and get a different perspective on things.
Okay, thank you very much, Peter. Once again, we're really pleased to have you here today. So I speak. Please, I move just the word to Peralta. Thank you very much, Peralta.
Okay, thank you, Peter. Thank you, Ricardo. Peter, I have one comment only.
Yes.
I think one of the biggest problem you can see now with the development of coronavirus vaccine, that is, you don't have too many, or maybe none, company that has interest in neglect disease or in parasitic disease. And it's very difficult for me, I think it's very difficult to develop only in science, because most of the parasitic disease, to us to develop something, we need money from the governments, and the government don't give the money to develop the vaccine.
And the private sector,
and the private don't want, because it's not profitable.
Well, even look at COVID-19, right? Why is Moderna developing an mRNA vaccine for COVID-19? Do they really care about COVID-19? I don't think that's their priority. The priority was a government stimulus package to accelerate their mRNA technology, and it got that whole mRNA through the FDA in record time. So now they could flip that around. Next time what they really want is an mRNA vaccine for cancer, or for, or mRNA gene delivery technology. And now there's precedent set by the FDA, and the government wound up paying for that whole clinical development. So I think that was the big driver for them, was the there was basically a stimulus package for them to get their technology through. Now, sure, there's national pride and all this kind of stuff. Same for Pfizer too. And you could say it's good that we'll have the mRNA now platform sort of established as more mainstream, but I don't think it was the attraction of COVID-19 even that stimulus. I don't think the companies are going to necessarily make money on COVID-19. Like Merck, for instance, when they developed the VSV vaccine for Ebola, if you talk to the Merck scientists, they'll say we lost money because we had to pull people from more money-making projects, even though there was some stimulus, so even with COVID and Ebola, it wasn't really, the financial incentive was not what we think the financial incentive was.
No, because that I believe most of the research has to be done in public. The company, they never.
And what's got to happen, I think, the G20 economies right now they're all hurting, but once they recover, and they will, one of the things I say in the book is we need greater financial contribution to global science from the G20 countries, which account for 86% of the economy. So, too much of the time it's all the US, the UK, and the Gates Foundation, right? And maybe a little bit France and Germany. We need, Japan, China, Indonesia, Brazil to, really expand the investment in science. But it's very tough to make it happen.
Okay, thank you.
Thank you.
And I look nice
my best wishes to everybody. So next year in Brazil. So this is...
yes, I hope
definitely.
So. Thank you very much.
Bye-bye. Thank you, Ricardo.
Bye, Peter. Thank you very much.
Eu gostaria, antes de terminarmos nosso seminário, de só dar uma palavra, como sendo talvez o último, quer dizer, talvez não, o último seminário desse ano. Lembrar a todos que nós estamos trabalhando para que o Congresso da Sociedade Brasileira de Parasitologia, nós já estamos avançando bastante, deve ocorrer na primeira semana de maio. Vocês vão receber brevemente, talvez até o final de janeiro, nós teremos tudo já organizado. Mas para organizar esse evento, nós também precisamos de ideias, precisamos também que os nossos colegas sócios e associados e sócios que aproveitem para ficar de sócio, que dê ideias, sugestões. Não quer dizer que nós vamos reter todas as sugestões, mas que a ideia não é fazer um congresso muito grande, porque ele vai ser todo ele virtual. Então, é um congresso um pouco mais enxuto, em que nós estamos pretendendo ter, em média, mais ou menos 12 conferências, 24 mesas redondas, não, 12 mesas redondas, 24 mini-conferências e umas 12 a 24, a gente não definiu ainda, apresentação oral. Então, vai ser um congresso mais ou menos com essa estrutura, para atender toda a parasitologia. Nós vamos dividir, talvez, em 4 grandes segmentos, entomologia, educação, eumentologia, protozoologia e... Voltando uma, não me lembro. Acho que é educação, entomologia, protozoologia e eumentologia. E esperamos, então, que todos compareçam nesses eventos e, mais uma vez, pedir a todos a procurar entrar no site da Sociedade, tentar ver, associar-se, e agora nós temos a facilidade de pagar com boleto, com cartão, a mensalidade da Sociedade. Provavelmente, no Congresso, todos os sócios, em dia com 2021, automaticamente serão inscritos no Congresso. Ainda estamos discutindo isso, mas é uma ideia da Sociedade que os sócios em dia sejam beneficiados com uma inscrição para esse Congresso. Já estamos negociando ainda para ver se temos condições financeiras de fazer o Congresso dessa forma. Então, mais uma vez, agradeço a todos por esses 6 meses aí de convivência. Espero que tenhamos atingido o nosso objetivo, que era levar um pouco da parasitologia aos colegas, nesse momento em que só fala em Covid, nós falarmos um pouco mais de parasitologia e, com isso, manter os colegas todos também um pouco ativos com a parasitologia. Então, agradeço e desejo um feliz final de ano, feliz festas, mesmo separados dos nossos parentes mais próximos, às vezes, mas que tenhamos cuidado, que o negócio está ficando perigoso. Então, aconselho evitar isso, mas a Sociedade vai estar aqui e qualquer coisa que necessite da Sociedade de Parasitologia, nós temos hoje o site da Secretaria da Sociedade Brasileira, é só escrever para a Secretaria, as opiniões para o Congresso, sugestões, podem mandar para a Secretaria, secretaria@parasitologia.com.br, né? Não,
.org.br.
Então, estão todos aí, estamos à disposição, queremos fazer o melhor possível e espero que em 2021 nós possamos ter um contato próximo como nós queremos com as pós-graduações e com os colegas. Inclusive, nós tivemos uma reunião recente e foi nos cobrado a parte de os representantes estaduais. Então, isso é algo que a gente quer ativar realmente em 2021, e aqueles já até posso ver com quem aqueles que interessarem nos seus estados, pelo menos um representante em cada estado a gente gostaria de ter, aqueles que se prontificam a fazer algum trabalho pela sociedade e querer levar a sociedade para o seu estado, já pode se candidatar, escrever para a gente, mandar para a secretaria, dizendo que tem interesse em divulgar a sociedade e ser um representante da sociedade. Então, hoje nós já temos alguns que já colaboram, mas são poucos mesmo, são uns 4 ou 5 só. Então, nós queríamos ampliar esse leque, pelo menos um por cada estado. Tá bom? Então, um bom final de ano aí, até o próximo ano, e eu passo a palavra ao Ricardo para destejar aí, para encerrar nossos trabalhos. Um abraço aí, Ricardo.
Obrigado, Peralta. Queria desejar a todos um excelente 2021, um ótimo Natal a todos. Repassar a palavra da Roberta Caldeira, nossa colega aqui da Fiocruz Minas, que o Simpósio Internacional sobre Esquistossomose vai ser presencial em Ouro Preto em agosto de 2022, estaremos lá e a SBP vai dar o suporte. É isso, que a gente tenha um 2021 excelente, todo mundo que esteja assistindo esse webinar, ou que venha assistir depois, lembre da sociedade, entre no site, o Peralta já falou tudo, precisamos dos associados para que a sociedade faça sentido, né? Um feliz 2021 a todos, muito obrigado, gente, até mais.
Até mais. Ricardo, fica um pouco aí, vamos ver, falar contigo. O Júlio fechou?